Sometimes we like to add terms of a sequence together, and that brings us to what are called partial sums of a sequence. That's what we're going to talk about in this video. So let's let our sequence be a sub 1, a sub 2, a sub 3, a sub 4, and so on. And our nth term will be a sub n. And notice I have it listed here, and it's an infinite sequence. Here's how we define our partial sums. The first partial sum is actually equal to the first term of the sequence. Then it starts to get a little more entertaining. The second partial sum is the sum of the first two terms of the sequence. The third partial sum is equal to the sum of the first three terms of the sequence, and so on. So the nth partial sum is equal to the sum of the first n terms of the sequence. In this case, a sub 1 plus a sub 2 plus a sub 3, and keep adding until you come to that nth term. And that will be our nth partial sum. And notice we use capital S for sum for these partial sums. So let's look at this sequence. It's a finite sequence with 7 terms, but suppose the question is to find the fourth partial sum. So S sub 4 would equal the sum of those first 4 terms, 2 plus 9 plus 16 plus 23, and for this problem, the other 3 terms of the sequence just aren't relevant. So when we add those together, what do we have? 50? So the fourth partial sum for this particular sequence is equal to 50. Sometimes the sequence could be given instead of a list, it could be given as a formula like this. Here's my sequence defined this way. A sub n equals 11 minus 2n. And suppose the question is to find the fifth partial sum. Well, in order to do that, I do need to find the first 5 terms of the sequence. So let's do that. We'll need a sub 1 and a sub 2 and a sub 3 and a sub 4 and a sub 5. And let's do all the calculation. We'll have 9 and 7 and 5 and 3 and 1. So the fifth partial sum would be the sum of those numbers, 9 plus 7 plus 5 plus 3 plus 1, which is equal to 25. So the fifth partial sum of the sequence that's defined by this formula right here is equal to 25. Let's do one more problem. This sequence will be defined recursively. We have a sub n equal to 6n plus 4 times a sub n minus 1, and our first term is equal to 3. And the question is to find the fourth partial sum, S sub 4. So here we go. We already know the first term is 3, but we need the second term, the third term, and the fourth term. So let's write it out. The second term is equal to 6 times n, and n is 2, plus 4 times a sub 2 minus 1. That's a sub 1. I'm just going to write out that formula this way. Let's go down and write a sub 3 while we're at it. It is 6 times 3 plus 4 times a sub 2. Notice in our formula, here is n, and this subscript is n minus 1. So whatever this number is, subtract 1, and we will have the subscript here. So a sub 2 uses a sub 1. A sub 3 uses a sub 2. And we need the fourth term as well. and it will be 6 times 4 plus 4 times a sub 3. Again, here's an a sub 4. That means we need the third term when we're trying to calculate it. So let's keep going. Let's pop in the numbers. Let's see, we're back up at a sub 2. We have 6 times 2 plus 4 times 3. I just substituted in a sub 1 right here. And let's do our calculations. We have 12 plus 12, that is 24. Let's move on. We're going to find a sub 3 now. We need to substitute in the second term. So here's our second term. It's popped in right here. So we have 6 times 3 plus 4 times 24. That is 18 plus 96, and that's 114. And we're going to pop our 114 into our expression to find the fourth term. So a sub 4 equals 6 times 4 plus 4 times 114. That's 24 plus 400, what is that, 456? And if we add those together, we have 480. So now we're ready to calculate the fourth partial sum. We know the fourth partial sum is equal to the first term plus the second term plus the third term plus the fourth term. And let's add those together. And we find that we have 621. So the fourth partial sum, the sum of the first 4 terms of the sequence that's defined this way, is 621.